next question, number 11. A resistance and a coil are connected in series and supplied from a single phase 100 volts 50 Hz AC source as shown in the figure below. The RMS values of plausible voltages across the resistances VR and coil VC respectively in volts are. So plausible means the voltages that can flow through those certain elements. So we are looking for any one of these four options. Let's see if we can find them. Now, in order to solve this, I think the best way to do it is by drawing a phasor diagram, because here our source is an AC source, so it always helps in order to see how the phasor diagram looks like. So since it is a AC source, we have the VC that is given over here, the coil, okay, the current and the voltage across this certain coil here. So VC is our hypotenuse. The angle phi denotes the angle at which the source is running at. So our horizontal component is VC cos phi. Our vertical component would be VC sin phi. Okay, so VR, we know that the phasor of VR is always in phase, so we draw this line here which is VR, and the resultant of VR to the point at the very end, okay, it's supposed to be a straight line, okay. So this would be the source Vs, okay, so we have the source over there. Now based on this we can write down an equation. So let's take the entire triangle. We write the equation, we use Pythagoras theorem. Vs square is equal to, now the sum of these two. So we have VR plus VC cos phi whole square plus this component here, VC square sin square phi. If we are to expand this, we get VR square plus VC square cos square phi plus 2 VR VC cos phi plus VC square sin square phi. Now this term here, VC square cos square phi and VC square sin square phi term becomes 1, since we know the relation that sin square theta plus cos square theta is equal to 1. So let's simplify. We'll get another sheet of paper here. Okay, so utilizing that, we get Vs square is equal to VR square plus VC square into sin square phi plus cos square phi plus 2 VR VC cos phi. So this is our expression. We used the relation earlier to turn this into 1. So we get VR square plus VC square plus 2 VR VC cos phi. So from here we can take out the expression for cos phi. So cos phi can be written as Vs square minus VR square minus VC square divided by 2 VR VC. So if we check the values that have been given to us, 65, 35, 50, 50, 60, 90, 60, 80. So basically we are supposed to find out what values of VR and VC would we get the cos phi as 0. So we have to check for each of these values here. So that's our aim. We are supposed to see that which values of VR and VC. The first set of values here correspond to VR and the second set correspond to VC. So if you substitute 65 in terms of VR, 35 in terms of VC and 100 in terms of VS, you should be able to get the value as 0. So check. So you will notice that A doesn't work. So you will have to substitute for each one. A, B, C and D. So according to the calculations, we see that D satisfies 60 and 80. So we'll just check that. So that's 100 square minus VR is 60. 60 square minus 80 square divided by 2 times 60 into 80. So if you solve this, you will notice that this is 0. So for all values for which cos phi is 0 is the right answer. So here D is the right answer. I hope this has helped.